Welcome back to Quack Fab. On today's episode, we're going to be picking up where we left off. I'm going to put this wheel back on and we're going to turn it, just find out where we could put a shock. As you can see here, there's not a whole lot of space. So I kind of already did this before when the wheels were spaced out a little bit further, and I measured the travel like fully up and fully down from here to determine the stroke of my shocks. So I got on a website, I'll have to find it and link it, and found shocks that had eye holes in the bottom and studs on the top that fit within the stroke range and the height range to fit on this vehicle. These are actually for a Subaru, I think, but I ordered them and I'm going to make them fit in here. At least I think I am. Somehow. Pretty much like that. I'm going to have to come up with some kind of stop to keep it from turning in too far, because right now it's, you know, it's going to hit the shock, and if it turns in any further, ow, you can see way down in there, I don't know if you can see that or not, it's going to end up hitting the lower control arm if I don't put some kind of stopper on it to limit the turning radius. Now I figured out exactly where I want this shock to be. It's just pretty much tucked up against this frame rail. You can see we had initially put the shocks right here, but that's kind of too far back. That's exactly where the tire goes. So I marked right here where my center point's going to be. Now I need to clean it off. I'm going to have to make some shock tabs. I'm going to do that with my plasma table. But you could do it with a cut-off wheel and a grinder. But I'm going to have to weld this shut before I firmly attach anything on there. Before I make some shock tabs, I gotta take a couple measurements. I'm gonna take my digital caliper here, and we're going to figure out how big this hole is. Looks like we got just a shade over 12 millimeters, 12.1 millimeters. And then I want to measure this just to make it kind of uniformy. Looks like we got about 40 millimeters, and we're going to take those measurements over to my CAD software. Here are the shock brackets. I don't know where my brother got them, but I'm going to see if I can't reuse them. If not, I'll have to cut some of these out and make them too. But in order to make the tab, say we need some circles. Put a circle there. We're going to make that was 40 millimeters. Enter, and wow, we need to zoom in. This software is a lot easier to use with a mouse, but I'm in my garage right now. I don't have a mouse, I just have my laptop. So we got our 40 millimeter outside diameter, and we're going to take this one. Oh, hold on, that didn't exactly hit the middle. Let's zoom in a little bit more. There we go. All right. And we're going to do I want this to be a little bit bigger or exactly the same size? We'll do exactly the same size. 12.1. Enter. All right. So now I got to make a little standoff for it. Take a rectangle. I guess we could just do that. How tall do we want to make it? We'll start off with 40 millimeters tall by 40 millimeters wide. So it's perfect. And then we don't really need all that stuff in the middle there, so we'll just cut it off. Cut, 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 cut. There we go. We can go to the, I don't know why my tools aren't fitting. There we go. There you go. That's the tab I'm going to make. But I'm not just going to make one, I'm going to make 4 of them. So we'll go ahead and copy that and paste it, maybe. But did it not work? Now it's working, whatever reason. There we go. Now we got 4 of them. Finish that sketch, and then we'll give it some depth, just so that we could see that these are our tabs we want to create. Okay, and now we got to go manufacture them. And we'll create a setup. But I don't know if I know we're not there yet. Before we do that, no, that is right. We got to do a setup. There we go. Whatever reason that did. There we go. Move our starting point over here to the corner. Okay, in the setup, for only thing we need to do, post process and put a 1 here. Then we got okay. Forgot a part. Four bodies. Post process 1. Okay. There we go. Good Lord, this thing is fighting me. Now we're cutting 2D profile. Now we get to select our machine. From my library, I already got a machine set up. There we go. And we definitely don't want to go on this fast. Not for 1/4 inch armor. Okay. Got our contour faces. Then our heights. Smoothing. Okay. Now we can go to post-process. There you go. That's the path it's going to take. Post-process. Shock tab for Frank. Frank. There we go, successfully posted. Sweet sauce. All right, so we can minimize this and minimize this, and we got to open builds. Open builds is free to use. Fusion 360 is also free to use. I didn't pay for any of this stuff. I mean, obviously I paid for the plasma cutter and the table, but not the software. If you start doing this to make a profit, then you have to purchase licenses for these softwares. All right, got my plasma cutter plugged in, hooked up. Piece of metal over there. Got my open builds all updated and stuff. Now I just need to connect the, open this up. I think I might have let you all seen this already, but anyway, I'll do it again. So that's the power supply and the controllers for the X, Y, and Z axis on the plasma cutter itself. But there's a USB cord that runs out of the bottom here that goes to my computer, and there's a Arduino in there that controls everything. So over here, just connect the Arduino. There you go, says it's connected. And we can push these buttons. You want to be careful how much you move it, because if you hit 100 millimeters and it's close to the wall, it'll try to move 100 millimeters and it'll make the teeth jump. So I like to start on 1 millimeter and then I hit the button. I don't know if you can hear that moving, but here, I'll show you. Okay, so we'll move up to 10 millimeters. There you go. But I like to, right now let's turn the plasma cutter off, because I want to run it first without the plasma cutter, so that we make sure that it's all going to end up on the piece of metal and not going off the side of it. But we need to first get it in place and then zero it. So we'll go there. And then we'll bring it over here. I guess it would help if we open the G code, which is the thing that we, let's see, we need, oh, one of them will work. Shock tab for Frank. Let's do that one. Yeah, see, it's telling you to home the machine. So let's see, it looks like I think it's going to go left to right. So like, I think it's going to go this way. But we have to, let's move the machine that way a bit. I think we can go left just a smidge. Yeah, that'll work. And then I really don't want to move 10 millimeters down, so we'll do one at a time until it touches. And then you hear click. There's the click. And then you raise it back up until it stops click. There you go. So now that we got it zeroed, you can go over here and you go set XYZ to 0. Now that's the 0. And what we're going to do is we're going to run the job with the plasma cutter off. We're going to see if it falls off or if it's going to cut everything
I sped this section up to 4 times speed just to show the path the plasma cutter will take and make sure the metal is large enough to accommodate all 4 shock tabs.
Ooh, just barely. That'll be fine. There you go, it's all done. So now we're gonna fire up the plasma cutter and we're gonna run it for real. Let's wait for it to get done. All right, it's on. Pressure's up, power's up. Run the job, and I like to put it on abort just in case something messes up. I just reach over and click the button. But I'm gonna watch from behind the camera so arc don't burn my eyeballs. There you go. 4 shock tabs. Yeah, you could do this with a cutoff wheel, but it's so much quicker to do it with the plasma cutter. And it's insane that plasma cutter can cut through that 1/4 inch armor plate that fast with those smooth lines. It's awesome.
Sorry for all the background noise. I had to turn the fan on to clear out the plasma cutter smoke. Here I'm just cleaning off the powder coating so I can get a clean weld. Now I'm positioning the shock to see how the tabs are going to line up. During this, you want to make sure the pivot point at the bottom of the shock is on the same plane as the control arm. Now that I have the position, I need to make the forward tab a little bit shorter so it would fit the angle I needed, so I cut a little bit off. I had the lower control arm jacked all the way up because this is the position that puts the shock closest to the frame. With the forward tab cut shorter, the tabs are lining up nicely for the angle and pivot plane I need. Now that I got it where I want it, it's time to throw a couple heavy tack welds on it. And it's holding on there nicely. My cousin showed up and I got distracted, so I didn't get the footage of me tacking the upper shock mount in place. But here you can see I am happy with the location, so I burnt it in so I can cycle the suspension to see how it works. It is cycling up and down nicely, no binding, no bending, and minimal deflection on the lower bushing. Now let's put the rotor and wheel back on to see how much clearance we don't have.
Well, there you have it. One shock installed. Ooh, look at that. Definitely gonna have to put some kind of stopper in there, or that is going to slice a hole in my tire. So we're gonna have to limit the turn somehow, which means we'll probably build something up in here to contact this to keep it from turning too much. So I'm probably going to put a little piece in there and weld that together, and it depends on how much that strengthens it up. I might make me a little piece to go here too, but we'll see. That's enough for today.
Thanks for watching QuackFab. If you have any advice or ideals, please leave a comment. If you enjoyed the video, please leave a like and subscribe, and I'll see you in the next one.